Hello Spartans, if you watched my previous video, you know that this is part of a larger recording I initially made. I have split the original video into two parts to make it more digestible. Some of the things I say during the video may not make much sense without this intro as context. I hope you enjoy watching the video as much as I enjoyed creating it. And we reach the last layer, fundamentals and subjects. And this is the part of the video that most of you have been waiting for. Now we are ready to map the upper layers to fundamentals and subjects that you should look for when you are choosing a university degree, a course, or perhaps a bootcamp. And in the spirit of academia, I have decided to split the fundamentals and subjects in two parts, bachelor's and master's. Because back when I was studying, I had a bachelor's degree, and then I took a master's degree as well. And the master's degree was more oriented to cybersecurity, while the bachelor's was more general and more oriented towards computer science. Without further ado, I will reveal the list of subjects that you should have in any university degree worth its salt. Starting from the top, we have digital systems and computer architecture, algorithms and data structures, object-oriented programming, operating systems, data stores, computer networks, software engineering, distributed systems, cloud, and finally reverse engineering. Every time I deliver a presentation, I always start with a motivation, because the motivation makes the presentation and the argument much more compelling. In this case, explaining how each of these subjects map to the cybersecurity field will make things much more clear. And I will start with digital systems and computer architecture. You start from the bottom and you learn how information is stored in computers. You learn Boolean logic, how memory works, how CPUs work, you learn assembly code, etc. Boolean logic is quite important for programming, while memory and CPUs are relevant if you decide to become a reverse engineer. And memory is crucial in the realm of digital forensics and incident response. Up next, we have algorithms and data structures. Programming language is simply a means to an end and not the end itself, which means that you can replace languages and still achieve the same results for the most part. Some people make the mistake of starting by learning a specific language, rather than understanding the fundamentals of programming languages. Learning a specific language, it's totally fine because it's a good starting point, keeps you motivated, it is much less dry than reading about fundamentals of programming languages. But it's important for you to study the later. If you understand how programming languages operate, what they solve, and how they organize data, you can easily jump from programming language to programming language. Knowing algorithms as a cybersecurity professional, it's a nice to have, but it's a skill that you are most likely never going to use. No sane person in this world memorizes programming language syntax anymore these days, unless they use that language on a daily basis. What tends to happen is that people understand what programming languages offer, they understand which programming language is more suited for the task at hand, and then the rest can be simply Googled. Understanding how programming languages interact with operating systems will help you regardless of the subfield of cybersecurity that you choose to pursue. And this gives us a nice segue into the next subject, which is object-oriented programming. Objects are everywhere in tech. JSON represents objects and so does YAML. Operating systems have internal structures to manage state, for instance processes and files, which are also objects. C# and Java, they are also object-oriented programming languages. Objects are everywhere, and having a subject that combines this concept with algorithms and data structures will help you adapt to most new fancy tech being churned out regularly. At the same time, you will learn design patterns, which is something that may be useful if you develop tools in the future or if you decide to become a reverse engineer. Because part of being a good reverse engineer is understanding how the compiled code is mapped to the original code, and understanding how this mapping happens requires you to an extent to understand design patterns, software engineering constructs, and also the mindset behind the developer's decision. We move on to operating systems, which was hands down my favorite subject when I was studying. It is true that you will be overwhelmed when you start studying operating systems, but a good subject that teaches you everything from kernel to processes and applications will help you immensely if you decide to become a threat researcher, vulnerability researcher, reverse engineer, security engineer, or even a digital forensics and incident responder. Bear in mind that a good operating systems course does not teach you how to use Linux or perhaps how to run commands on a shell. It teaches you instead what is a shell, and what lies beneath the graphical user interface that you interact with. Up next, we have data stores, and in the realm of tech, there are many ways to store data. You have file systems, you have database, you have blob storages, etc. Databases are a common subject in any university curriculum, but here I'm suggesting a broader subject that discusses the multiple ways that data is stored and processed. Data is the new gold, and attackers know that very well, which makes understanding this asset a must for both red and blue teamers. At this point, we have stayed only in a single device, up to the level of operating systems. But computers interact between themselves, and this is where computer networks come in. Networks are the glue that brings all of these together, and understanding how endpoints communicate and the OZ model will help you regardless of the subfield of cybersecurity that you choose. Next, we have software engineering. Now, why is software engineering part of my list? Software engineering brings the fundamentals of programming languages and object-oriented programming together and adds more design patterns, processes, and tooling. You may spend your entire life without ever needing to write a single line of code, but not being able to do it will severely limit you, as I mentioned before on other videos. There are plenty of opportunities for you to optimize existing processes and bring in new ideas to your company, which will make you stand out. Being a certified button clicker can only get you so far, and this point is made more clear on my video named The Top 5 Commandments of an Elite Cybersecurity Professional, which, as usually, I will link in the description. Besides, by understanding the processes and tooling behind the software development lifecycle, you will better understand potential attack or defense points. And we are back to red and blue teams. Now, networks are great to connect computers, but no sane developer is nowadays building network packets and processing them to build a distributed application. It doesn't make any sense, and it simply doesn't scale. Existing applications are built on top of protocols, and where I mean protocols, here I mean abstractions that help them scale. Abstractions stimulate adoption because they make the complex tech more accessible. Distributed systems are no more than abstractions built on top of computers, network hardware, operating systems, and firmware. They are an essential component of any university curriculum. The cloud brings together all of the concepts above as a massive abstraction. While there are many cloud providers, the concepts underlying all of them tend to overlap. As an example, entities, access control, networking, and data storage are something that you are going to see across all the major cloud providers, and the naming conventions tend also to be the same. Given how omnipresent the cloud is nowadays, any university curriculum worth its salt should include this subject. Finally, we have the subject reverse engineering, and I was a bit unsure whether I should put this here or not. But then I realized that reverse engineering once more is simply a means to an end. It doesn't have to be associated with malware analysis or vulnerability research. It's just a way to get from point A to point B, where point A is the final product and point B is the beginning, the process behind the product and the components of the product. In the realm of cybersecurity, reverse engineering can be used to understand malware and to find vulnerabilities. And while this is an advanced subject for bachelors, the fundamentals of reverse engineering should be taught and then revisited again in a master's degree to be applied to specific areas. Having a good understanding of these subjects, you will then be in a position to move to a more advanced master's degree, where each subject is in essence a role at the company. And these are the subjects that I recommend. Starting from the top once more, we have digital forensics and incident response, cloud security, threat research and malware analysis, threat intelligence, application security, identity and access management, offensive security, vulnerability research and exploitation, security operations, governance, risk and compliance, physical security systems, and finally, human psychology applied to cybersecurity. Most of the subjects are self-explanatory except for two of them. The first one is identity and access management, which is in essence a core pillar for any organization. As I mentioned before, users and teams within a company are mapped to the digital realm using entities such as users, roles, permissions, etc. In this subject, you will discuss the concepts of authentication, authorization, administration, and auditing and reporting. The second subject that is worth clarifying is human psychology applied to cybersecurity. And while I expect that the offensive security subject is going to address social engineering, a subject fully dedicated to human psychology applied to the cybersecurity field is a must to understand the triggers used to exploit and manipulate people in the real world. And this, folks, is the CyberSpartan framework to map cybersecurity down to its core skills. Regardless of which country you are in, this framework will work just as well. Nothing is clear-cut in life, and there are two factors to bear in mind. The first one is depth of the course, and the second one is subcomponents of each subject. Because yes, there is another layer, which is the layer of concrete technologies and protocols. For instance, a computer networks course may talk about RIP, BGP, VLANs, SIP, etc. with different depths. It is impossible for me to discuss these or provide a more in-depth framework because each institution will have a different perspective on what is more or less relevant. However, I envision that if the subjects I mention or at least a flavor of these appears on a curriculum, you are most likely covered. A university is not meant to teach you everything, it is meant to give you a map and then it's up to you to explore further. And Spartans, we have reached the end of this video. Hopefully you will find this framework of good use, and if you have any tips to improve it, leave them in the comment section below. Until next time, stay safe, stay paranoid.